Okay, girls, in this video we're talking about the real number system. So all the numbers that you've ever dealt with in your life have been real numbers. There is a whole other number system that you don't know anything about yet, and you won't know until you're in upper school, called the imaginary number system. So there you go. So we're talking about the numbers that we know, okay? But we call them all real numbers. So we divide them up into 5 categories, and that's what you see on this page. So what I want you to do is fill in the information that I fill in and the examples I fill in, and this will be added to your notes, and you'll need to study. You'll need to know these categories and what their definitions are and the kinds of numbers, be able to give examples of numbers that go into each of them. But know that all 5 categories of numbers that you see here all make up the real number system. So we're going to start in the very inner circle with natural numbers. And natural numbers are what we also call counting numbers. So think about when you were a little girl and you were learning to count, right? You always started with 1, like counting on your fingers, right? So the counting numbers start with 1, then go to 2, 3, and so on forever. They're all positive, they're all whole. What you might notice is that 0 is not included. And think about that. When you learned to count, you didn't start with 0, right? You started with 1. So counting numbers are all the numbers that are whole and positive, starting with 1. So when you see a whole number like that, you know it's a natural number or a counting number. But you will also see examples where it's written as a fraction form, and it's considered a natural number because when you reduce it, it reduces to a natural number. So we have to include different forms of numbers, even though they may not look whole, but they reduce to a whole value, so we have to use them. Now, one of the number forms that I'm going to start showing you quite a bit in this lesson are what we call square roots of numbers. And so, you know, when you square a number, you multiply it by itself, right? So when I do 2 times 2, 2 squared, I get 4. So 4 is considered a square number. So I can go in the reverse. Instead of going 2 times 2 and getting, 4 as a result of 2 squared, I can take the square root of 4 and get back to the number that I squared to get there. That's called the square root of a number. And so for perfect square numbers, numbers whose square roots are whole numbers that we squared to get those numbers in the first place, those would be considered counting numbers or natural numbers because they simplify to a whole number. Another example would be like the square root of 9. Well, what number times itself gives you 9? Well, that's 3, and 3 is a natural number. So you might see examples that are not written as a whole number, but they reduce in some way to a whole number, and therefore they're called a natural number. All right, speaking of whole numbers, officially whole numbers, so whole numbers, do you see how the natural numbers are a part of the whole number set? So whole numbers are all the counting numbers plus 0, okay? So we define whole numbers as all counting numbers or all natural numbers, okay, plus 0. So whole numbers are going to be starting at 0 and going up, right, in whole number values. So again, you can express those in different forms. For example, if I have a fraction that is 0 in the top and some number in the bottom, that's considered a whole number because it reduces to 0. Again, I could do the square root of like 16, which means what number times itself gives me 16, and that equals 4. So square root of 16 technically can be classified as a whole number. It can also be classified as a natural number, right? It could go into both categories. So some numbers are members of multiple number groups, okay? And so now I want to go to the next circle, which are the integers. And integers are defined as all the whole numbers, right? So all whole numbers and their opposites. So that's their definition. Now, 0 is included, okay? So this includes 0. Okay? Even though 0 doesn't have an opposite, it is a whole number, and therefore it is part of the integer family. Okay? Now, all natural numbers are integers, because all natural numbers are also all whole numbers, are whole numbers, right? So do you see how each group builds into the next, but with every new group we add more numbers to that family or to that grouping, right? So natural numbers are counting numbers. They start with 1 and they go on forever. Whole numbers are all those counting numbers, but now we're going to add 0. So 0 on up would be whole numbers. And integers are all those whole numbers, so from 0 on up, whole numbers, plus their opposites. So that includes negative numbers. So we're going to add things like, I'm going to write in green, like -7, right, would be an integer. -15 over 3, because that reduces to -5. Obviously 0. We could do a square root if we wanted to. We could do like the square root of 4 in there, right? Those would all be considered integers, okay? And then finally we get to this outer circle, which are called the rational numbers. And the rational numbers are any number that can be written in fraction form. Okay, so any number that can be written as a fraction is considered a rational number. So that includes all fractions, all decimals, right? When I say all, I'm going to put a little star by that because I got a group of decimals that it won't work for, but most decimals. It would include all integers, because to make an integer a whole number, I just put it, or a rational number, a fraction, I just put it over 1. So like -7 down there, right? If I do -7 over 1, that's a fraction. So that makes it a rational number, okay? A mixed number like 4 and 1/2, that would also be rational, because I can write that, right? I can turn it into a fraction by calling it 9/2. A decimal, 0.1, because I can write that as a fraction. That's 1/10, 1 over 10, right? 6.2. And they can be negative, right? So I could have -1/3. Any number that can be written as a fraction is rational. Whole numbers, like 8, right? Just like with -7, to make it a fraction, I just put it over 1, right? So rational numbers include all integers, all whole numbers, and all natural numbers. It's a big, big number set, right? So it adds onto the natural, whole, and integers, it adds on the fractions and the decimals. That's where they go, right? But so when we start down in the very smallest circle, natural numbers, those are the most limited set of numbers, because it's just from 1 on up, whole values. Then we expand that out and we take all those numbers and tack on 0, and now we've got the whole number family. And then we take all those whole numbers from 0 on up positive, but then we add their opposites, the negative whole values on the other side of 0, and that would be our integer group of numbers. And then we expand that out and we include all those numbers, all the naturals, all the whole numbers, all the integers, and then we add in our fractions and decimals, right? Any number that can be written as a fraction can be a rational number. So now that leaves us with a special group right down here, and those are the irrational numbers. So do you see how that circle is separate from the others? That's because none of the numbers in the irrational group are members of any of those other groups that you see: natural, whole, integer, and rational. So the definition of a rational number is any non-terminating, that means non-ending, non-terminating, and non-repeating, right? So they can't repeat, because repeating decimals actually can be written as fractions. Okay? So any non-terminating, non-repeating decimal is what we call an irrational number. The most famous irrational number of all is pi. Pi is 3.14, blah, 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 on and on forever, right? But you could also see something like this. You could see 1.763 dot, dot, dot. When you see that, that means that decimal is going on forever without repeating, without stopping. And then also, and I'm running out of room, so I'm going to do this down here. If I take the square root of a non-square number, that number is always going to be irrational. It's always going to come out to be a decimal that goes on forever and ever and ever. So remember, a square number is any number that I get when I square some other number. So for example, right, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25. These are all square numbers, okay? These are all square numbers, and so therefore I can take their square root, right? The square root of 4 is 2, and the square root of 9 is 3, and the square root of 16 is 4. See how that goes? But if I take the square root of something like 15, there is no number times itself that gives me 15. So that's what we call a non-square number. And when I take its square root, it's going to be an irrational number every single time. Okay? So those are your 5 major groups of real numbers, and you need to memorize their definitions and be able to give me examples of numbers that will fall into those categories. So make some flashcards, do some studying, and make sure you've got this. And if you have questions, you just need to let me know. See you next time.